is my minion now,
Isn't
and
it?
I'm quite pleased with it.
It's we're live, by the way. It's magic.
Yes,
I really like OBS, and it's unfortunate that I kicked a huge amount of money for
Wirecast.
Wirecast, yeah, and it was
Yeah.
just I could never make it go. I was struggling with it all the time. It's really like I'm sure it's more powerful, but for me it was incredibly complicated. While OBS is just an absolute crowd pleaser. So I'm
Yes.
yeah.
Okay, so I'm tweeting this out. Now, the one thing that's been kind of perplexing me is it seems like YouTube is constantly tweaking the way their live events work such that it's hosed us a couple of times on eating an event and like starting a new feed in a random location.
Did that happen this time?
This, I don't think it happened this time, but I'm trying to figure out the magic by which it sometimes decides to hose you and sometimes decides you're good to go.
I don't know what to say. Now apparently we're a half hour early.
No, we're the time that was
Yeah.
listed on the website.
Uh,
I am
maybe,
looking at the time on the website.
maybe, but I wouldn't be surprised if somehow there was a mistake somewhere. But so people are sort of kind of going. There you go. See, Gator's like, I thought we were starting in half an hour. So, apologies. Okay, so I don't know if this happened, and we don't really, we're not going to be able to troubleshoot it at this moment.
Yeah.
But what can happen is that Susie books a longer time for when we have slotted for the show. So we start in our calendars half an hour early, and then end at the 15 minutes, I think, after the show actually ends. So that's how much time we have on our calendars. But the time that is actually for the live event, and so it's possible those got crisscrossed. I don't know. And I hate to do this to everybody, but we're both super time constrained. So yeah, there you go. Phoenix it does say 12:30. So
Okay, I'm looking at our website. I just went off of the website.
yeah,
I'm laying
no, and
that way.
I went off of the calendar. So apologies to everybody. We're just gonna have to do this because we both have to book out really quickly. So we're just gonna have to do the show. Man, so sorry. I am sorry.
You said that so
Didn't I say it's so Canadian?
Canadian.
Doesn't that make it like twice the sorry when a Canadian says it? Yeah.
Yes, yes, it does.
Yeah. All right. Let us get cracking. Start your recording.
I am recording.
I,
It's doing it right. Life is good. Okay.
all right. Here we go. Astronomy Cast, episode 479, Single Stage to Orbit. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how's it going?
It's going well by the time folks are listening to this. I will be in Amsterdam where I'm going for the European Testing Conference, which you heard some ads for on previous episodes, and life is good. And I'm slightly madly packing still.
You're
Blah.
gonna be you're gonna be testing. You're gonna be conferencing. You're gonna have a good time. And I'm back from Iceland, having spent the last week with Paul, Matt Sutter, and 35 of our good friends as we noodled around Iceland, and it was an amazing trip. It was absolutely wonderful. I highly recommend going to Iceland. We saw glaciers, we saw waterfalls. The coolest thing was this amazing bay where glaciers are calving off icebergs into this bay, and then these icebergs are sort of flipping over, and they're bright blue when they turn over, and then they're making their way out this bay because it's actually a fairly rapid channel, and then they go out of the ocean, and then they get thrown back on this beautiful black sand beach and turned into these crazy ice sculptures all the way up the beach. They call it the Diamond Beach, and that was the coolest thing. The craziest part,
Like You saw calving like in process?
No,
Like,
no, no. We didn't
okay.
actually see the calving, but we saw the results of it. So there was tons of these icebergs slowly making their way down. So I could only assume that it had happened fairly recently. And then but the craziest part was this enormous storm blew in, and it was like once a year, really powerful storm, and the winds were like, I forget, 45 meters per second. They measure wind speeds in Iceland at meters per second, and so you had these gusts of wind, and it was I've never experienced wind like this in my lifetime. It was the craziest thing. So anyway, that had to sort of stopped us from being able to do a couple of the events. But Paul and I put on a bunch of shows. We just had a great time. So if that sounds interesting to you, we've got another one coming up, which is going to be in September. We're going to be doing a cruise in the Eastern Caribbean. We're going to go to the Kennedy Space Center. We're going to do shows on the, live shows on the boat. We're going to bring telescopes and binoculars and do observing on the deck, teach you your constellations. So check that out. Go to astrotours.co, and then you can find the Sea and the Stars cruise with Paul. And then Pamela, you're going to be doing an event later on. So there's a bunch of stuff. Check out astrotours.co, and you can see the upcoming events. All right, to celebrate the launch of the Falcon Heavy, we figured it was time for an all-new series, this time on the rockets that carry us to space. Today, part 1, we're going to talk about single-stage to orbit rockets and why they're so difficult to make them go. All right, people are pretty familiar with rockets, but just give that quick explainer on, how does a rocket work?
The most simple way of looking at it is it's a highly controlled explosion where the entire explosion is going out a small shaped exit hole in the opposite direction of the rocket in which you're hoping to travel. So with the Saturn V, you want to go up, therefore the explosion is pointed downwards. That's the simple way of looking at it. The unfortunate reality is your controlled explosion only lasts as long as you have fuel, which means you have to carry a whole lot of fuel with you if you want that explosion to last a long time. And it takes a whole lot of stuff to hold in that fuel and control that fuel, because if you stop controlling it, you go kabloom, and that isn't the
Right.
desire.
But I think that the thing that's really interesting about rockets is, for example, the Space Launch System with its amazing RS-25 rocket engines, it is throwing out material out the back of the rocket. The explosion is causing the propellant to go out the back of the rocket at 13 times the speed of sound. And thanks to Newton, if you throw something away from you at 13 times the speed of sound, you get a kick in the opposite direction. For every action, there is an equal and opposite reaction. And
Conservation of momentum.
And that is how rockets work. And that is why they work in space. They work in the atmosphere. They work wherever. Throwing things away from you makes you move in the opposite direction, which is everywhere.
And rockets are driven by all that basic physics stuff where you are taking liquid gases. So liquid oxygen is one of the main things that we hear about when we're listening to prep for launch. And then they kind of expand it into a violently expanding heated gas. That phase shift causes it to go from, hey, I'm hanging out, I fit in here nicely, to I no longer fit, I must explode out the back end of the rocket. It's this explosive change in temperature and volume of space required to hold the stuff and things that drives the material out the back end of your standard rocket. Now, there are other ways to drive stuff out the back end of a rocket. We've talked about ion drives before, but that is not going to get you off the surface of the planet.
Right.
To get off the surface of the planet, we're looking at controlled explosions, and people keep trying to figure out how to do it using jet engines, but we're not quite there yet.
Right. Well, the problem with the jet engine is that it uses the atmosphere as its oxidizer. It brings in oxygen, uses compressors to mix it in with the fuel, and that's what allows the jet to carry less fuel and to be able to fly with a rocket, because you're not going to be able to pull in that atmosphere from the air. You need to carry that oxidizer along with you, and the oxidizer is heavy. So that's just goes along for the ride. All right. And now the traditional, when we think of the rocket, we think of like the Saturn V rocket. We imagine this gigantic, pointy, thing filled with fuel, and the key is that it's going to have multiple stages. So why do rockets have these stages?
Essentially, it's so that you don't have to keep carrying your garbage with you. At a certain point, you have a mostly empty tube because you've used up fuel, and it is going to save you how much fuel you're going to use towards the end of your acceleration if you aren't carrying your garbage with you. So you use up all of the fuel in the first segment of your rocket. Let me start that sentence over. You use up all of the fuel in the first segment of your rocket, and now you have an empty tube filled with hardware. So drop it. Now you're burning fuel in the second segment of your rocket. You empty all of that out, you drop that. This is part of why rockets launch off the East Coast out over the ocean. It's because they drop stuff, and we don't want to drop them on people. So we simply risk anything that happens to be out in the ocean.
We're looking at you, China. Have you seen what they've been doing? They've been dropping stages of their rockets into suburban areas.
Oh, geez.
Yeah, because they don't. Yeah, no. Well, it's intended. They don't have a lot of space. They need to launch their rockets. And some people live downrange of the rockets, and so stages are coming down in their backyards. It's they're being kind of careful about it, but still, it's you should look this up, that what's happening with some of these Chinese rocket stages that are happening in China. And they're actually looking to do reusable rockets, but that's probably a whole other show is where we talk about reusable rockets. So, but let's get back to single stage. All right, so that's the traditional rocket, that you've got these multiple stages. Why carry extra engines and just empty tube when you've used up all of that fuel? Get rid of it. Move on to the next one, get rid of it, move on to the next one. The Saturn V had 3 stages. A lot of rockets have 2 stages. When you think about the space shuttle, right, it had those solid rocket boosters and that big main fuel tank. So there's different configurations that go. And so but the question is, obviously, this is super wasteful to take beautiful space shuttle main fuel tanks, lovely Saturn V first stages, and just throw them in the ocean. They cost millions of dollars. Why can't you just launch your rocket to space?
Because we're still working on figuring out how to get the mass to thrust ratios so that you're in orbit when you're left with an empty tube. And that's really kind of the question mark on why hasn't this happened? Well, it's because we haven't figured out how to complete the entire trip to space before our tubes are empty. And now what we're looking at is there's a number of companies that are like, okay, we need to solve this. And they're taking a variety of different approaches. And one of my favorite approaches is, we don't need so much rocket fuel if we're not trying to launch so much stuff at once. And this is the approach that's being used by ARCA. It's a 4-letter acronym that I've been unable to figure out what it stands for. On their own website, they just say ARCA everywhere. So ARCA is a company out in New Mexico that is looking to figure out how to launch just 100 kilograms at a time. Your standard overweight American couldn't be launched on one of these rockets. And at 100 kilograms at a time being launched, they only need a single stage. And you look at their rockets and you're like, huh, that would fit in my driveway. They're cute, they're tiny, and they can launch from New Mexico because they're a single stage, which means they have no garbage to drop on the rest of the continental United
Right.
States.
But then explain what the process is going to be for that. So you've got this rocket that is a single stage, but the Arca rockets aren't reusable, right?
No, no. So many of the others that they're working on are reusable. Other companies are working on reusable. With Arca, they have a very different design for their engines than at least I've ever seen before. They kind of look like someone took a tube of toothpaste and turned it into a rocket. The butt, instead of having the cone-shaped engines that we're used to, instead has this weird, flat, completely different style engine.
Kind of looks like a razor to me. Like a
Yeah, I can see that too. An
yeah,
electric razor, maybe.
yeah.
And what they're looking at doing with this electric razor shaped rocket is they believe they can get, first of all, more thrust for their engine. And then they're also confining themselves to trying to launch lower mass payloads. So you don't need to have as much fuel in general to launch that lower mass payload. So by staying small, by finding a way to, for their limited payload, being able to eke out more thrust per pound of fuel, they're looking at being able to get up in a single stage, and they're also looking to lower the costs. Here, we really have to look at cost per pound versus cost per launch, because per pound is really what's going to matter. If you're launching a little tiny rocket, it's going to have a lot less stuff and things that you have to pay for, less fuel, less engine bits. All of that brings down the cost. So when I say we're talking about $1 million a launch, it's like, oh my gosh, that's free compared to 150 million for the Falcon Heavy. But it per pound, we're looking at about $2,000 per pound. And so while it is cheaper than the Falcons, it's not hugely cheaper. It does offer this neat flexibility, though, of now, instead of having to be able to wait to launch out of Wallops, having to wait to launch out of Kennedy, any of our East Coast launch facilities, they're now looking at New Mexico. So Spaceport America has one more purpose for existing.
Yeah, well, the advantage to this is that you get to put your satellite where you want it to go. You don't have to tag along with where everyone else is going to go on some Falcon Heavy that's got satellites stacked in it like cordwood. You get to have your satellite follow its own personal trajectory. It's a custom experience. Okay, so that's the Arca. One thing I don't know if you knew, some rockets right now, I think the Atlas are actually capable of single stage to orbit. They don't do that, and they wouldn't be able to carry any significant cargo.
And they're not FAA certified to do it.
No, they're not. No, they're not certified. But they are. If you run the rocket equation on these rockets, and they didn't really have any kind of payload, the rocket could, with the amount of fuel that it carries, with the amount of thrust that it can put out, it could carry itself entirely to space. But what is the point? I think this is a challenge that people have been struggling with for a long time. I think originally the space shuttle, with certain levels of its reusability, it was hoped that they could come up with some way to make it a reusable spacecraft, a single stage to orbit. And I think the greatest example where NASA took a really big swing at it was the X-33, which was the Venture Star. Have you seen? Do you remember that spacecraft?
Right, and the one I always think of is also the DCX.
Yeah,
and
very similar configuration.
But what's interesting is these ideas haven't completely been abandoned. There's still under development, as far as I can tell, the Skylon space plane.
Yeah, we'll get to Skylon. We'll get to Skylon in a second because it's an interesting take on it. But for those who aren't aware of what the Venture Star was going to be, it was this collaboration, I think, with Lockheed Martin. I apologize in advance, but and that it would it would take off, fly to space, and then it would have this lifting body design, so it would be able to, like the space shuttle, return to land. It would be able to carry some cargo, and then it would refuel, and then it would be able to launch again, which has a tremendous amount of advantages. I mean, we're seeing what's happening with the SpaceX launches, how that level of reusability, there's a certain streamlinedness. It makes it feel like an airplane, where you get in the airplane and you take your cargo and then you land and you get in, and the other people get in the airplane and then they go again.
And the X-33 was a NASA funded sponsored project that was under development down in Johnson, as well as, of course, with the different companies that were working on it. And it's one of these things where there's always the question of, will that resurface as something that comes back for continued development? Or has it simply been covered up and swept in under the military, if you believe the most amusing of the conspiracy theories?
I never do.
I don't either, but they amuse me, which is why I do look at them occasionally.
But about a decade ago, they abandoned the X-33 project. They were having trouble with the composite. They had to build these special composite fuel tanks, and they couldn't get them to hold. They couldn't get them to handle the pressure to be able to hold the fuel, and they had to essentially abandon the entire project. Although, I'm sure there were other difficulties to go along with it.
And so while that one has been abandoned, we do see other companies that are working on similar things. McDonnell Douglas with their DCX Delta Clipper, and the one that has a completely different design that so with both the DCX and the X-33, so McDonnell Douglas versus Lockheed Martin, we were looking at these pretty much triangular spacecraft, fully reusable, launched and took off in a vertical alignment for the DCX, launched vertical, landed on a runway, I believe, for the X-33, or was dropped and took off for the X-33. It was unclear what they were looking as their final design. With those, it's all launch and go, come back, triangle. Yeah. But all of us have ever wanted is that plane, that plane that takes off on a runway, like the 777 I'm getting on tomorrow, and then lands safely on the other end, having done whatever it needed to do in space. That point-to-point, regular, everyday user experience that we were promised in our science fiction.
Now we'll talk about Skylon.
So Skylon takes us back to the idea of the riding a controlled explosion aircraft. It is very reminiscent of the old 40s and 50s space suborbital space jets. It's being developed by UK company Reaction Engines Limited, and it's basically a tube with stubby tiny wings that have very powerful engines attached to the sides.
And the engines are what makes it special.
Yeah, we're starting to look at an interesting hybrid system, and this has kind of been every engineer's dream design, where you have something within the atmosphere, works like a jet engine, above the atmosphere is able to figure out other ways of getting that oxidizer mix into your fuel, so you can keep going without having an atmosphere around your spacecraft.
Yeah, and I mean, man, the Skylon fans are legion, and they are excited, and they can't wait for this thing to fly. But it's coming out of the UK. And the problem right now is that it's essentially like an engine prototype. Like there's not a lot more that's been built up yet. But if all goes well within the next, decade or so, you can imagine this configuration. This thing sits on the runway, uses its jet engines, goes down the runway, flies up into the air, accelerates using the air as its oxidizer, pulling oxygen out of the atmosphere, gets to a certain speed, gets to a certain altitude, switches to these engines turn into rockets essentially, and it then is able to continue its journey into orbit. And if you can pull that off, it is a very impressive feat.
And they're hoping that they can start testing in the next year with trips to space by 22. So we could be within 16 months of seeing test flights. I'm not sure how well I believe that, but I want to believe it. And they have fabulous graphics. And they say things like they'll be able to reach speeds of 19,000 miles an hour, which would cut the journey from London to Australia to 4 hours.
I do not want to take that trip, but that sounds terrifying. But imagine, right? You've got this thing. You put in the cargo. It flies to space. It dumps its cargo to space. It then re-enters the Earth's atmosphere, lands on the landing pad, takes another payload. The price is only the price of fuel, and you could get the cost of carrying these payloads down to, I think it's about 1,000 pounds, about $2,000 per kilogram to carry this stuff into space, which is good. It's a very competitive price compared to some of the other options out there.
And I think this is one of those times when units were actually friendly. I think it is roughly 1,000 pounds per kilogram or $1,000 per pound, roughly, depending on the day.
Right.
So, with this particular designed space plane, they're looking at 200 reuses per vehicle, 270 feet long vehicles. So these are big. We're looking at roughly the length of a football field, and each one will cost just under $1 billion, depending on unit conversions on the day of the week. And the trick is that 200 different times they can fly. That's what drives the price down.
Yeah. And so you can imagine it could be ready to fly again within a couple of days, could fly hundreds of times before needing a complete retrofit. So that is a very exciting technology, but then we really need to just kind of wait to see how this is gonna play out. The challenge is you're never gonna get with here on Earth, and with using chemical rockets, you are never going to get the rocket equation to work in your favor that a single stage to orbit rocket is ever going to match the amount of payload that can be carried with a multi-stage rocket. Like, it's just, you're having to carry those fancy engines and those really cool wings and all of that tube with you to space to carry the cargo. And so unfortunately, it's that reusability that gives you the advantage, as opposed to the I guess what's going to happen with a multi-stage rocket.
And as we begin to use lighter weight things, we already have the CanSats, CubeSats, microcubesats. We launch tiny stuff on a regular basis. The Bigelow inflatable modules don't weigh that much. One human being who's not an overweight individual can be launched on some of these things. We're looking at ways to get that. I need to get 100 kilograms, 200 kilograms to space, and that's it. We're looking at getting the costs for these small things down, while also looking for ways to build bigger and bigger rockets. So this is a multi-pronged approach. Just like you were saying, let's get that custom launch vehicle for your one payload of several universities projects that are all CanSats. Okay, fine. Let's throw all of you into a similar orbit. We're launching all of you together and it's cheap. Let's use Skylon to get these lightweight space station components up and then drop a single human up there. It's these lighter weight things that we're opening the door for that will no longer have to ride piggyback waiting for someone with a big heavyweight cargo to need
Right.
that lift.
Now I'm assuming, I don't know what your plan was for this next few episodes, but we'll be talking about, I'm sure we're going to come back around and talk about reusable rockets.
Yes.
SpaceX with the BFR, with the big Falcon rocket, the big fabulous rocket, is I think is kind of planned to be the best of both worlds, because you're going to have a staged rocket, but both stages are reusable. And so it's going to launch in a stack, and then the first stage is going to return to Earth, like we've seen happen with the Falcon 9, and then the BFS, the big Falcon spaceship, is also going to be able to return to Earth and land and be reusable, and then get stacked back up again and do it all over again. It feels to me, and as we see this actually play out, that is, until we get a more exotic kind of fuel, when metallic hydrogen becomes available, right, we're going to see that is going to be, I think, the lowest cost, the most efficient, most reusable. It's going to be that combination approach.
It still has that backlog of having to launch out of a very limited geography.
Yes.
Whereas single stage to orbit, it suddenly allows us to use Mojave, to use all of the West Coast locations, to use Spaceport America in New Mexico for more than just suborbital. To be able to say, we're going to launch 100 kilograms to low Earth orbit in a single stage, and hey, we can do all those launches from this completely new location. It's just like opening an extra line at the grocery store. Suddenly more people can check out faster.
Yeah. All right. Did you have a plan for how many of these you want to do?
I think we keep going until we realize we've talked about all the things that are super cool.
All right. That sounds awesome. Thanks, everyone. We will see you next week, Pamela.
See you next week. Right. And now we
Save.
I'm going to be so jet lagged next week. Maybe, I don't know. I'm going to Europe for 3 days.
I was ruined. When I went to Iceland. Not at all bad coming back home, but I was totally destroyed going over. Oh.
See, I usually run into issues coming home rather than going there. I don't know why. That's just my body.
Yeah, for me,
works that way.
Going east is brutal, and then west is okay.
Yeah, I'm exactly the opposite. This is 479?
Yeah.
Okay.
And export. All right. Apologies. I think we've got about 10 minutes, and then we've both got to book out of here. So hit us with your questions for 10 minutes. Again, we deeply apologize for getting the start time wrong. Somewhere there was a malfunction at the junction, and we will be back at a regular time in the future. You're uploading your file.
Oh, crud. You're right.
I can see you're just completely bandwidth hogged. Michael Zand suggests plasma, fusion, fission, antimatter, and don't forget the EM drive. Yeah, we might do an episode on some exotic propulsion systems, especially fission rockets, because they are super legit. They totally work. And the EM drive. Where are you at on the EM drive? Totally. Okay.
I don't think we're there yet.
Well, I mean, the EM drive, if it works, then it completely violates our understanding of the laws of physics. So that's a tall order to make your.
I like ion drives. Yeah.
Yeah.
Just stick with the ions. Ions are good.
Yeah.
They do.
Astro B says it's time to build a space elevator. The problem with the space elevator is great on the moon or Mars, but we're at the exact limit of material science, literally the theoretical limit of what's possible with material science on Earth. Ben
And
Appleby's
it also wrecks a whole set of orbits.
right, yeah. But then if you've got a space elevator, then you don't need so many orbits.
But those don't help for like weather
Weather
and
satellites
communication.
and yeah.
Yeah.
Ben Appleby asks if the BFS can get to orbit on its own, what's the point of the BFR? Cargo.
Yeah.
So the BFS, the big fabulous spaceship, the big Falcon spaceship, and then the BFB, the big fabulous booster, will get stacked on top of each other to form that staged rocket. Yeah, the BFS will be a single stage to orbit spacecraft. It can launch on its own to orbit and return and land. So that's amazing. But you just won't be able to carry very much cargo. But you stack it on top of the BFB, and now you've got some serious cargo to orbit.
And I don't think it's single stage to orbit from the surface of the Earth. I think it's from the surface of the moon or Mars.
No, I understand that it is.
Oh, okay.
I just talked to a SpaceX expert yesterday about it, and he was saying that the BFS is single stage to orbit from the surface of the Earth.
Okay.
Yeah, but that's him. Chris Profit wrote SpaceX from the ground up. So if what I just said was wrong, it's totally his fault. And
fair.
Yeah. Let's see. Anyone else? Sylvan Westby likes the infinite improbability drive with ludicrous and plaid speed.
Yes, please.
Yes, please. Whoa, that's a tough question. I don't know if you want that one. Arjone, at the end of the universe, would all virtual particles become real because of the expansion, sort of like Hawking radiation at the event horizon? So would virtual particles if the expansion of the universe is happening so fast, would virtual particles get torn apart? I guess it just depends on whether dark energy is increasing or not, right? Because then you get a big rip. So, if you get the big rip, then even black holes are getting torn apart. But if not, then the expansion within a cubic meter of space remains constant, so you don't have to worry about it. Did I just answer the question?
No. Okay. So the idea of virtual particles becoming real particles implies that the exchange bosons and the temporary birth of particles and their antiparticles out of vacuum energy would cease to function the way it currently works and would instead have particles that popped into being and sat there going, "Hi, I'm a particle.
I'm violating the laws of physics."
Well, not so much violating probabilities.
Right.
So I don't see that physics changing. The Hawking radiation works because you have a particle and its antiparticle popping up on opposite sides of the event horizon, and the other's like, "Wait, I can't get back to you. I shall fly away and mourn your loss," and thus evaporate a black hole. With space expansion.
But I guess that's the question that Arjone is asking, is that can the expansion of space act the same way as providing an event horizon that one particle would fall into? Could space be expanding so quickly that they appear and they can't get back to each other? And so what I was saying was that only if the big rip is happening, otherwise the expansion of space will never be fast enough on a per meter basis.
Well, in the fullness of time, but the vacuum energy will be so decreased at that point that I think the answer is no.
Right. Yorn is recommending people look at Isaac Arthur's channel, Orbital Rings, Launch Loops. Yes, agreed. Check out Isaac Arthur's channel. He's got a whole bunch of ways to get to space, and it's super fun. Any other questions? No, I think we better wrap it up.
Okay.
I'm feeling nervous about the my time to get out of here, so I better shut this down. Thanks everyone. Sorry about again. I apologize. You get my double Canadian sorry, and we will see you all. We're going to be back same bad channel, same bad time next week.
Normal Friday.
Right on.
And if you're in the European Union, I'm doing a meetup in Amsterdam near the train station on Sunday. Please RSVP. Only 2 people have RSVP'd, and this makes me feel unloved and sad.
You guys are going to have a good time.
Okay.
You both get to, the 2 of you will get to capitalize the conversation with Pamela. It'll be great.
Okay.
All right. Let's wrap things up. Thanks everyone for watching. Thanks as always to the WSH crew for the chat. And we will see you all next week. Have a safe trip, Pamela.
Thank you. Bye-bye.
Oh, I learned something important. Hold on 1 second. Okay.